All right, good morning, everybody. Welcome to Augmented World Expo. This is training day, starring Denzel Washington. No, seriously, we have here an amazing speaker, which has been doing a lot of work to actually help everybody in the community understand what are the augmented reality SDKs out there, and kind of the only independent source that can really give you a sense of what it is. So that was last year. This year, we're upgrading it with some new SDKs and also have a focus on wearable SDKs. So this is, I think, the first ever comparison of some of the leading SDKs out there with the different glasses. So I think it's going to be a really cool session. Please join me in welcoming Patrick O'Shaughnessy.
Thank you, Ori. And Ori wanted me to mention to download the Vuzix app. So make sure to do that. Welcome. Everyone excited to be here? I know I am. This is going to be an amazing AWE this year. Just amazing what's been coming out, even since last year. So as Ori mentioned, I'll be giving an overview of SDKs for digital eyewear or smart glasses. And then David Beard will be here from Vuforia to talk about their latest and greatest from Qualcomm. And Ryan Burgoyne will be here as well, sitting up front. And with that, let's get started. My name is Patrick O'Shaughnessy. I am the founder and chief developer of Patch Reality. Patch Reality creates custom augmented reality and digital eyewear apps. These are some of our customers. We've been doing this for about 5 years now, and we try to use the best in breed technologies for our clients depending on their project needs. So that's my quick pitch for my company, and now we'll get into the content. So as Ori mentioned, this is a little bit of a departure from my talk last year. Last year it was more a little bit of a deep dive into exactly the nuts and bolts of how you build a project for mobile devices. And if you want, you can check out the slides and video from last year to get a good overview. That the content hasn't changed all that much in terms of the workflow. Some of the features have gotten better, and there's more widgets to play with. But I thought this year what we would do is instead concentrate on the on the eyewear space. So this is the grid that we had from last year, and I refreshed it for AWE New York. And I'll be putting the slides online. The only real point I want to make about the AR SDKs that I covered last year and earlier this year in New York is you'll notice in the column on platform, nearly all of them support Android. And as it happens, all the digital eyewear I'll be talking about today also runs Android. So you can conceivably run any of these AR SDKs on the digital eyewear, but they won't necessarily give you an eyewear optimized experience, especially with the see-through eyewear. But just keep that in mind. These are some of the others that I covered last year. But what I want to focus on today is the eyewear itself, the SDKs, and the programming environment that the digital eyewear companies provide, as well as some third-party tools that have been specifically tailored and added features to their SDKs to target the eyewear specifically. Just to get a quick read on the room, who here considers themselves a developer? Okay, looks like maybe about half. Of those, how many people have developed for Android? Okay. Anybody here have developed yet for a digital eyewear like Google Glass or any of the others? Okay. And then who knows somebody that's developed who's a developer? Everybody raise your hands. All right, good. So hopefully this will be good content for you to at least know the capabilities that you can get with today's state-of-the-art hardware. So the eyewear that I'm going to be covering today is the Vuzix M100. Looks like this. Goes over your head like that. The Google Glass, which everyone's, I'm sure, seen by now. Looks like that. The Epson Moverio, which I have over here, looks like this. Has a little trackpad and unit here. And the Optinvent Aura 1, which looks like this here. Now, one thing that struck me as I was putting this talk together is it's kind of reminiscent. I don't know if you can cast your mind back to the days when we all had personal digital assistants like the Palm Pilot, or my favorite was the HP 200LX. And then we kind of made that transition from personal digital assistants into what's now considered the modern smartphone with a multi-touch interface. And pretty much every phone that you guys have in your pockets probably has some form of multi-touch swipe, interface, no keyboard, camera, etc. We kind of somehow standardized. Apple led the charge on that. That hasn't happened yet for digital eyewear, and I'm not saying it's going to happen, but we're in a situation now where there's a lot of similarities in the eyewear, but I think the industry is still working through some human factors to figure out, what do we do with our hands? Do we swipe the side of our head? Do we tilt do we use our head as input? How about winking? Maybe we should wink at the device. Should we talk to the device? What context is that appropriate? Should we have a separate keyboard and mouse in our hands while we're looking at the eyewear? So there's a lot of things that come with having a computer on your face, and this is the answer that these vendors have come up with. So let's talk a bit about the programming environment. At the base level, again, all of the eyewear I reviewed runs Android. So if you're an Android developer and you've used the Android Development Toolkit, you will be very familiar with developing for this eyewear, at least for native apps. You're going to be using a lot of the same libraries for things like location sensing, if the eyewear supports it, or accessing the sensors, the accelerometer and the gyro, etc., the compass, for displaying content on the display, getting user input. A lot of that is very much the same. If you step up a layer, there's actually an SDK usually provided by the eyewear vendor themselves, or at least some special firmware hooks that provide features that are specific to that platform. And we'll talk a little bit about what those might be. And then sometimes that's a very thin layer that really just makes it possible to develop for the device and not much more than that. Sometimes, like in the case of Google, it's a very deep and wide UI paradigm that they're trying to impose on their ecosystem. And then stepping one more up from that, you've got your third-party SDKs. And those provide specialized features that you're not going to get from the vanilla eyewear just by itself. So things like being able to recognize gestures through the camera, or doing stereographic AR, through see-through AR, doing tracking, image recognition, those types of things you're going to tend to get in a third-party SDK, at least in the situation we're in now. I imagine it's possible there will be eyewear companies that kind of go up to that level as well, but at the moment this is kind of the situation we're in right now. So this is an overview of the eyewear that I reviewed, and the different features that they each have. You notice they all, again, run Android. They're slightly different versions of Android, so you want to make sure that you're targeting the right API level when you're developing for a particular device. Then the next column is about the features that the vendor themselves provide in their SDKs. And you'll notice when you look at the slide, one thing that jumps out is that of all of them, Google Glass is really kind of the one of all of them that provides this environment that they have decided they want you to program like. And, they want a particular user experience for their users, so they're providing things like gestures on the swipe device. They're providing voice activation, access to the camera in a specific way, some UI widgets for scrolling cards, etc. For the most part, the other three that I reviewed, if you decided that you wanted to just eschew their SDKs altogether and just treat them like an Android device, you pretty much can. But they do provide some specialized capabilities specific to their hardware. Like, for instance, in the case of Epson, they let you swap between their handheld sensor, which allow you to get accelerometer data and gyro data out of the handset, as well as they have a separate set of sensors in the eyewear. And so they have a mechanism in their SDK that lets you swap between the two. Moving over to the input types, again, they're somewhat different, each of the devices. In the case of Vuzix, you have a gesture sensor on the side of your head that's just senses in-air gestures or in and out, and we'll talk a little bit about that later in the talk. They have some limited voice capabilities, at least on the home screen. And I won't go through all the details on here. Some other pullouts is, of course, the Epson has both sensors and also 2 displays. It's a stereo display. So depending on your application, you may or may not want to take advantage of the fact that it has a stereo capability. Let's see. In terms of the display, the vendors tend to talk about their displays as, imagine you're sitting in your living room and you see a 42-inch screen and it's, 10 meters away. And for me, that's kind of hard to visualize. I like to think of it more like with the devices that we actually carry around with us. So for Google Glass and Vuzix, it's kind of like if you took your cell phone and held it 12 inches in front of your face and looked up to the right. That's about what it's going to look like through glass if your phone was see-through in the case of glass. In the case of Vuzix, it's opaque. In the case of Moverio, it's more like you take a 7-inch tablet, maybe your iPad mini, out of your bag, or your Android tablet, and you hold it up about 12 inches from your face. And that's about what the display looks like through Moverio. And then the Optinvent is somewhere in between. It's maybe a phablet. You can hold a phablet up 7 inches or 12 inches from your face. That's kind of the experience you're going to get out of that device. And then the cost is what the cost is. All right. Now, moving on to the third-party SDKs. I've broken it down by the type of eyewear that vendor supports in their SDK. And you'll notice, looking ahead, pretty much, for the most part, everyone has targeted glass. They were the first out of the gate. They made a big splash, and everyone thought, well, I better have some, everyone who's developing for digital eyewear targeted them first. But you're starting to see some vendors like Mateo and Wikitude do some capabilities for the Moverio BT200. And that's one of the most exciting things for me, particularly at the show this year, is to see that we're finally seeing this vision of truly see-through augmented reality, where you're looking at the world, you see the world as the world is, and you see the virtual content as virtual content, but they're married together in a beautiful way, hopefully. Now, we'll talk a little bit more about where we actually are on that vision, but it's just to me, it's just outstanding that there are vendors already tackling this problem and looking at this problem, because I think that's where we as an industry are headed. So a little bit about some of the eyewear-specific features. I kind of already mentioned that the BT200 is stereo AR, so both Mateo and Wikitude have a feature in their SDKs to support that. WearScript's kind of an interesting animal, which we'll talk about, because the programming environment for that is HTML and JavaScript, and you do it in a browser. That's really great rapid prototyping environment. So we'll talk more specifically about each one as we go along. Here's some more third-party SDKs here. Moving on. All right. So you've got the digital eyewear in your hand. And again, I'll have the slides online after the show, like I did last year, in case you missed all of the detail on that slide. So let's say you got your digital eyewear, you want to develop applications for it. The typical on-ramp for any of the eyewear is you first obviously need your dev environment. You get your Android developer kit or your Android Studio, whatever your preference is. You get the eyewear vendor's drivers and SDK. You need to enable the debug mode on your eyewear, which is a little bit slightly different for each eyewear depending on the user interface paradigm. Some of the eyewear requires you to add a little configuration to your Android environment, and this is because not all the eyewear is recognized, has a recognized vendor ID in the vanilla Android SDK. And that's something that can sometimes trip people up if they forget to do that and they're banging their head on the wall trying to figure out why can't this computer see this device that's sitting right next to it. Optionally, if you are doing something specialized and you need a third-party SDK, you'll download that, and then probably you'll install and run some examples, look at the code, and get your feet wet. So I'm going to talk in detail, some detail, about each of the vendor SDKs. This is not going to be a deep dive like last year. This is kind of giving you a flavor of what each of these SDKs offer, what are the capabilities that you get out of them. So starting with Google Glass, you'll probably see this message if you do any development for Glass, because it does tend to run hot, especially if you're trying to do AR on Glass and keep the camera open for any extended period of time or do anything fancy with the GPU. So I figured that screenshot would be good for a chuckle. So Google has provided has provided basically two main avenues to get an experience on their eyewear. The first is the native approach. Well, actually, first was the Mirror API web-based approach, but then they've recently come out with a native approach. On the native side, they break it down into two different categories. And who here is not familiar with how Glass works? Anybody? So we all pretty much understand there's a timeline with cards and you swap between them. Okay. So they've got two different approaches. You've got this live card approach where there's a card on your timeline that has some data that can be updated, refreshed. You can swipe it away, come back to it, the data will have updated. And then the immersion, which is more like a traditional Android app. It actually takes control of the device, lets you do user input live on the app, and then it goes away. It doesn't exist on the timeline at all. And then the second approach is this web server-based approach where you're manipulating cards on the timeline. You're pushing a new card to the timeline. You're getting perhaps some user input, like they're speaking some reply, and then you're pushing another card to replace that card, or add another card. So those are kind of the two paradigms that Google provides and the way they like you to develop for their device. Of course, there's the third option, which is not on the slide, which is go rogue. Just use the Android SDK, use Unity, use whatever targets Android, and do whatever the heck you want. That's always an option. Very quick overview. This is probably the quickest overview you'll ever see on Mirror API setup. There are going to be other talks during the show, I believe, that go a little more into detail on the specifics of developing for Glass. But to give you a flavor, you're going to create a Google App Engine instance. You're going to create a console project. You're going to enable the Google API for that project. You'll create some OAuth authentication, put that secret into your quick start project. They provide like a Python or a Java or a Go implementation that you can use. You deploy that using Google's tools. They have a nice UI that you can deploy all the bundled assets and everything that go into a project right to the Google App console, or they have a command line. And then you're going to tweak your application, add cards, add responses, etc. And that's kind of if you're a web developer or you have an app that is very card centric and asynchronous, this is probably the approach that you're going to take. For the GDK setup, you can get that right inside your Android SDK manager. You just tick the box for the Google Development Kit preview, and it is a preview, so you can expect that if you create an app for Glass, the next time they update the software, it will very likely break. I've had this happen at least, I can't count the number of times. Probably with every update since I wrote the app, it has broken something. So just keep that in mind. I'm not going to go into all the features of the GDK, but I'm going to try and hit some of the highlights that no matter what kind of app you develop for Glass, even if you want to go rogue, you're probably still going to want to use some of the APIs I'm going to talk about because they make it possible for your app to live on the Glass. And the first is a voice trigger. There's really, that's kind of the way that Google has given us to launch apps on the device. You can also put a card on the timeline, which is the first approach that people took. But this is kind of the recommended approach now. So the first thing you do is you create an XML file. You can call it whatever you like. In this case, we're calling it voice trigger. You give it a keyword, which is just a string that appears on the glass that the person can talk to launch your app. In my case, I created one called Play the Game, or in other, and then from there you modify the Android manifest to add an intent to your activity of type voice trigger. You point to that resource that you created in the XML space. You can optionally give it an app icon to show up when somebody just taps the side of their glass. And then you have to enable a special permission, and this is important. Again, this is one of those gotchas that if you forget to do it, you'll be scratching your head while your voice command is not showing up. If you haven't used an app, a Google-approved voice trigger, or submitted your voice trigger for acceptance by Google and they've accepted it, then you have to put this permission in there to allow your particular voice prompt to go onto the device. So this is what it looks like. You say, OK, glass. The trigger that you've defined goes up in the list of triggers. And this is what it looks like when you just tap the side of your head. You can see that the icon you've defined shows up, as well as the voice trigger. The next thing is swipe gestures. So Google Glass has this nice trackpad on the side of your head, and so they provide these what's called a gesture detector. And it's pretty straightforward. You create a gesture detector. You add a listener with some callbacks that you get for specific activities on the device, like a swipe down, a swipe forward, a swipe back, it's tap, long press, etc. And one important thing that you need to do is you need to extend your activity with override the generic motion event and actually pass those motion events to your gesture detector. Just creating the gesture detector and attaching it to your view doesn't enable the gesture detector. So you have to make sure that you're taking all the events that are coming, the raw events, and pass them along to the gesture detector. It'll make sense of them, parse them out, figure out what constitutes a swipe, etc. Okay. The card is kind of the center of the universe for Google Glass, and Google's made it fairly simple to create them. They have some templated card types. So you just create a card, you set some text on it, maybe you set a footer or an image layout. You get the view back from the card, and then you can take that view and you can add it to your activity directly, or add it to a card scroll view, which is a nice additional UI widget that they've given you to actually be able to scroll between a list of different cards that you've created. And then once you've done that, it kind of looks like that. If you want to show a cute puppy, you can, with a few lines of code. So that's about the extent of what I wanted to talk about for the specifics of developing for Glass. And again, check out some of the other tutorials in the show if you want a deeper treatment of that. The next eyewear I'm going to talk about is the Vuzix M100. And what did I do? Oh, yeah. So this one's an opaque monocular display device. It looks like this. They have different attachments. It's got this base unit that comes off, and you can put it on some, like safety glasses. You can put it on this over the head mount. It has some buttons on top, 3 buttons, a volume up, down, it's kind of a combination back button, as well as you hold it to go back, you press it for OK. It's kind of a multi-use button, so there's 3 on top, there's a power button. Oops. And again, they have this gesture detector on the side. It has a microphone as well as a camera out the front. This is what the display looks like on the home screen. To set up the M100, you first need to get an SDK license from Vuzix, register your user ID. You'll want to install the Smart Glass Manager. This is Vuzix Android application that goes on your phone that provides you with a mouse touchpad on your phone as well as keyboard input because the input on the device itself is limited. You'll definitely need that to get the device into debug mode so that you can actually navigate the menus properly. You may possibly be able to do it with just the buttons on the device, but it's a little kludgy, so I would recommend you get the Smart Glass Manager. The SDK for the M100 is pretty much limited to an emulator, which is actually kind of a nice thing to have. They provide an emulator for the device that you can run on your PC while you're developing, so you don't have to push every change to the device itself. And Vuzix is one of the vendors where you have to add their particulars to the USB INI. This is what the Smart Glass app looks like. And you see that it's got this trackpad. It gives you a display of what's on the screen right now. You can bring up a virtual keyboard. And this is what the emulator looks like. There may be an updated version that looks more like the device. This is an older version of the device, but it basically provides the ability to emulate the keys on the buttons on the device. I'll talk quickly about the gestures, and actually as I'm going through I'm going to try and point out some of the currently known limitations of each of the devices so that you can be aware of them. And all of the things that I'm going to talk about across all of the vendors are issues that the vendors are already aware of, sometimes because I told them about them. But they're all well-known issues, and they're working on them, so you can expect they should be getting fixed soon. But in particular on the gestures for Vuzix, I personally found them to be just way too sensitive. So you can try swiping forward, and it's in the air, so it's not where you're touching the device. I would find that you would get different, like a rapid-fire series of events, like I'm swiping forward and I get a swipe back followed quickly by a swipe forward, and things were jumping all over. So I think they're still working through some issues on that. So for now, I would say if you're going to develop for Vuzix, you probably want to stick to the buttons or make use of the Smart Glass app for user input. But if you were to if you want to try the gesture input, they use the standard sensor APIs in Android. You just pass in a sensor type of 15, and you'll get back these numbers, which correspond to the left, right, and they've got a gesture which is bring your hand near to the device, and the gesture that's bring your hand far away from the device. And they also generate key events, so you can just key off of those. And so, which also the buttons do key events as well. If you wanted to be able to distinguish between gesture versus keys, then you'd want to use the gesture sensor. Okay. Some other limitations that I found on the device. If your application, so let's say you have a current application that you want to port to Vuzix, and it makes use of some of the Google Play services or Google Location services, they are not currently supported on the device. And actually, I don't know if Vuzix has plans to support them on the device. Also, there's a known issue with the GPS provider. There's no location provider now, so you essentially cannot use GPS right now on the device. We talked about the gesture sensor. And the voice commands right now are limited to the home screen. They don't have a means right now for you to actually use voice commands inside your own app. So you can use voice commands on the home screen, like left, right, up, down to navigate through the menu, or select those types of words. They've got a list of keywords that they recognize on the home screen, but it's going to be another rev or two before they allow you to actually add voice capabilities to your own apps. So that's the Vuzix. Next I'm going to talk about the Epson Moverio BT200. That's this guy right here. So the interesting thing about this, I I don't believe Epson intended this for you to walk down the street, obviously. I mean, you may want to, I don't know, but it's up to you. This is more for industrial applications at the moment. They are working on consumer level version that's lighter weight, and I believe also working on one that's going to be even higher end than this. But this is actually a big improvement over their BT100, which was much bulkier. Some interesting things about this is, again, they provide the CPU and the battery and the trackpad input in a separate device that you hold in your hand. It's actually quite a nice touchpad. You can really navigate around the device well. It's got a couple of hard buttons for your Android, typical Android home, back, menu, and then some specialized keys for operating the volume, switching between 2D and 3D, and brightness, that kind of thing. On the eyewear itself, they do have a camera. If you're going to be doing applications that use the camera, you'll have to note that it is a fairly low resolution camera. It's just VGA, which is somewhat unfortunate, I would say. But the display is beautiful. What else can I say about the device itself? Again, it's got sensors both in the head and the hand, and an API to switch between the two. I can imagine some interesting applications where you're figuring out where the person's hand is oriented while you're also switching back and forth to figure out where their head's oriented, especially in an AR context, so it could be really killer. So that's the Moverio. In terms of what they provide in their SDK, again, they provide the ability to swap the sensors, the ability to switch between 3D and 2D, and I think there's some small thing about the camera, but that's it. Pretty much from there, you are talking about developing an Android application targeting the Android tablet UI. So if you're developing an Android application for a tablet UI, developing for the Moverio is pretty much exactly the same. You're using all the standard Android SDK tools. The setup for the Moverio was really super easy. You can use the touchpad to turn on USB debugging. You can add a vendor ID to your USB INI. If you want to make use of the special switching between 3D, 2D, or switching the sensors, you can get their SDK, but otherwise just have at it and write your application. Epson also had some limitations that we bumped up against. They also do not have Google Play services, and they also have a GPS provider issue that they're working through. And then we'll talk about the AR SDKs in more detail, but there is currently and this is not necessarily a Moverio issue, but it's something that needs to be worked through with the vendors. So that's it for the Epson. That's if you've done Android development for tablets, then you'll be pretty comfortable with it. The Optinvent Aura, that's this one right here. They've also made some interesting choices with their eyewear, which are pretty cool. It doesn't work so great with prescription glasses, so I'm gonna put them on like this. They do have a little magnetic insert that you can get that has prescription that can be prescription. That you can pop on so that you can wear them and see what's on your eyewear. It is a see-through device. Another unique thing they've done is they allow you to flip it down to look away, so that your forward vision is not obscured. But then they also have it so you can flip it up and look through the device. It is a see-through device, so it'd be suitable for see-through AR type applications. They have this their trackpad is actually somewhat similar to the Epson one, different from the Google. It's an actual mouse-like interface that shows a little pointer moving around. So it's a full trackpad on the side of your head. So you don't have a separate device like in the Epson, and you're not limited to just swipe gestures like the Google Glass. They have a camera on it. And the sensors that you would expect, GPS, 9-degree axis motion sensing, and I think that's about all I need to say about that one. So moving on, what did I do with my glasses? I can't see anything. Okay. There we go. All right. This is what the home screen looks like on the Moverio. Looks just like a tablet. This one was probably the easiest to get up and running. You don't even need to deal with the USB config. You just use the touchpad to enable USB debugging. They do have an SDK. It's a very specialized SDK. It's if you wanted to write your own application kind of similar to Vuzix's application or any other application that has Bluetooth communications happening between the phone and the eyewear, then they provide an SDK so that the Aura can act as both a Bluetooth server and a Bluetooth client and can pass communications back and forth. But beyond that, again, it's just the Android tablet UI for the device. The GPS was working on the unit that I had, and also they do have Google Play services, so they have Google Maps, they have all of the Google specific APIs. I did notice one issue. One thing I did with all these when I got them was I ported my Star Trek game to them just to see how they worked, and I did notice that the Optinvent, their gyroscope is not reporting a gravity vector properly, and they're aware of that issue and they're working through that. The Optinvents are kind of the new kid on the block. I'm not even sure if you can actually get these yet. They're still a very much pre-production device, but for a pre-production device, they've actually got some really interesting capabilities. So that's it for the actual eyewear itself and what the vendors provide you in terms of your development environment. I'm going to move on to some third-party SDKs that I looked at that provide some capabilities above and beyond what you get from the standard Android or the vendor SDKs. The first one I'll talk about is Mateo and the Epson Moverio. And again, this was super exciting to me. I was like, oh, finally, I've been doing this for 5 years. I'm going to get to see a see-through AR stereo experience. And it actually is kind of interesting, but there are some issues with it in that the alignment's not quite correct. Step back a little bit and talk about the challenge of doing stereo see-through AR. If you look at a device like the Moverio, you'll notice that the camera's off here to the right. So it's not actually seeing the world as you see it with two cameras coming straight out of your eyes. So there's and I'm sure Ryan could talk to this because this is kind of what he does, but there's a calibration that has to happen to move to align the image that the camera's seeing with what you are seeing, and make sure that the content is aligned with your field of view properly. And in the industry, they call it hand-eye calibration. At least that's what Moverio refers to it, which goes back to robotics, where they have a camera on the hand of the robot, and I think that's why it's called that. But anyway, suffice it to say, it's aligning the virtual content with what the camera is seeing and what you are seeing. More importantly, it's close, but it's not quite there. And there's some speculation that perhaps some of the vendors like Wikitude and Mateo had gotten some units that were slightly different than the production units. They were pre-release units, so I'm sure that in short order they'll probably have these issues sorted out. Enabling see-through AR with Mateo is pretty straightforward. You can set your own manual hand-eye coordination if you'd like. I think where this is going, most likely, depending on how close you can get with just calibrating the device itself without accounting for the differences in the distance between people's eyes and how far away their eyes are from the display, you might be able to get good enough. But I think where eventually you probably have to go if you want to get it perfect is probably the vendors are going to have to provide an end-user tool so that the users themselves can calibrate what they're seeing, or at least give developers tools so they can tweak the calibration that Mateo's provided, or that Wikitude's provided, or eventually Vuforia maybe has provided. Sorry, Roy. I don't have any insight, but hopefully. So In order to enable it, you set the stereo rendering to true, you set see-through to true, and you set the see-through color. In this case, you want to set it to black. So anything that's black is going to appear see-through on the device. It won't have a it won't be displayed. And that's that. They do have, if you don't set the hand calibration, or if you call the set see-through to true, they override it with whatever they've provided as the calibration. Okay. And then moving on to Wikitude and the Moverio, they also have a see-through AR capability. It is also not completely aligned yet. The content, when you look through it in 3D, stereographic, looks slightly shifted to the left and down. It is kind of nice though, because it actually is coplanar with the paper, so you don't have to cross your eyes to look at one and then uncross them to look at the other. Like they're actually together. It's just they're slightly off. And you can see that in the photo here. I tried to take a picture through the eyewear of what I was seeing. This little red outline is supposed to be around the guy's helmet, but it's shifted over from where it's supposed to be. And there's another picture of it. I took one of their samples and I put the exact picture of the target into the system, and ideally those should have aligned so that you see the transparent image of the surfer dude right over the real surfer dude picture. But anyway, all the vendors that are working on this are working through these issues, and it's just exciting to see that they're working on this problem. Okay. In terms of one thing I wanted to point out with Wikitude is they do have some native code in their jar file, and by default the Android Developer Kit has this little checkbox that says force an error when the external jars contain native libraries. So you're not pounding your head on your desk. There's a little pointer for you. Just uncheck that box and you'll be fine. It's in their documentation too, but you know, who reads that stuff, right? You just charge in and start developing, and then you hit the errors and try and figure out what you did wrong. Wikitude also has a Vuzix M100 specific SDK that does see-through, not see-through, but video-based AR. Personally, I find that video-based AR on eyewear, unless you've got a pretty massive field of view, even then it's a little bit off-putting. For some reason, it's more natural when you're looking through a tablet to see content, video aligned, versus when you've got a little postage stamp up in your right-hand corner of your eye. You're looking at the real world. It's really big. You're looking at the virtual content and the rest and the real world replicated in this small postage stamp. But for certain applications, it could be interesting if it's maybe quick or the small augmentation. I don't know. We'll see. But anyway, it's there for your use. And again, any of the AR SDKs out there that provide targeting of Android, such as Vuforia or any of the others, should be able to run on the devices in a video see-through mode. I'm sorry, in a video not see-through mode. Okay, moving on. Are there any Unity developers in here? I forgot to ask that at the beginning. Oh, all right, great, my people. So if you want to do stereo VR on the Moverio or other eyewear that comes out down the road with stereo, you want to check out this FOV to go component. It's really great. It kind of worked pretty much out of the box when I ported my game over, and it looks like that. It's by Stereoscopics, or Stereo. Yes, Scopic. Yeah, right. You want to make sure that you're using the squeezed. There's a little tick box that says squeezed. If you'll notice in the screenshot, the content looks squeezed. Because what Moverio does is they take the full, was it 960 by 640 screen, and they cut it in half, and then they take each half of that and they send one to the left eye and one to the right eye, and then they stretch it out to the full resolution on the left eye and the full resolution on the right eye. So you need to pre-squeeze it so when they stretch it, it looks like it did in the full screen, if that made sense. So that's that. That's a nice little component if you want to provide a stereo experience. The next SDK I'm going to talk about is OTG platforms. They currently have an SDK that works on glass. I think they're going to be targeting other eyewear as well. It may actually work out of the box on other eyewear. So what they've provided is the ability to do hand gestures with glass using the camera. So you can swipe in front of your head, right, you can swipe left. You can make gestures like a closed hand, looks like this. They actually have an interesting demo where you can close your hand in front of you and move it out and in to zoom in and out of a photo. They also recognize an open hand gesture. So that's an interesting one if you have a hands-free type of application, maybe a medical situation where the doctor can't be touching their face or other implements, and they want to be able to quickly move through things. Or you want to walk down the street looking like that. Catchoom is an interesting one. They have a cloud-based recognition engine. They've recently optimized their application for glass. The interesting thing about this SDK is they take a portion of the image. They do a region of interest that that's I don't know if you, that part there is what gets sent to the server, and what that allows is somebody can hold what they're scanning a little further away from their face because they know what's being scanned, and it also reduces the latency going back and forth to the server to do the cloud recognition. So what you do is you embed their SDK, you go to the Catchoom website and configure the image database of what you want to recognize. They send you back an ID of what was recognized. You can connect that to your database or do whatever you want with it to show information about that image that was recognized. Maybe you want to play a video, maybe you want to do whatever, do a point of purchase. So it's a nice simple SDK. The next one I want to talk about is WearScript. This is really kind of one of the most innovative, maybe, of what I looked at, or at least the most different. It's really a really interesting rapid prototyping environment for Google Glass. What they've done is they've created this APK and other libraries that you load onto your glass. And we've got this one line install that pulls the code down. And installs the APKs necessary to run it onto your device. You connect your device by scanning a code at api.wearscript.com. You do some authorization with Google and with GitHub. When you launch the app, you go into playground mode. Then you have on the website at WearScript, you have an HTML and JavaScript playground that lets you pretty much do almost anything on the device. You can push cards to the device. You can get the sensor input from the device. You can even get a camera feed from the device. And it's an interesting environment to play with, especially if you're a web developer. If you have a web development bent, this might be the route you want to go. It kind of looks like when you're in the console, it sort of looks like this. You can edit your script. You can automatically, save that off to a version in GitHub, anyway, it's an interesting playground if you want to do rapid prototyping of your glassware. And I think there's a session tomorrow that's going to go into a deeper dive of what that environment is and what you might want to use it for. I just found it really interesting. Another really interesting thing that they've done is they've taken, remember I was talking about that problem of calibration. They've, for glass, figured out a way to take the video that the camera sees, that's up here in the upper right hand of your eyewear, map that, what's, you know, where the prism is in relation to your eye. You know, there's some calibration that needs to be done. It's going to be different for each device and each person. But once you have it calibrated, what you see, the video feed you see through glass matches what you're seeing in the real world. And then from there, that enables obviously the ability to put on that video some content. So while what you're seeing is small, at least it's aligned with the real world. So for instance, I'm looking over there at that exit sign. I would only see the video of the exit sign, even though the camera is seeing all these lovely people in the front row and this stuff over here, but I would just be seeing the part of the view that my actual eye is seeing. And I thought that was really innovative what they did there. And I think that if you know the vendors that are providing video-based AR, I think if they're going to do video-based AR, I think this is the kind of approach we probably want to see happen. And it'll also be useful for see-through AR, obviously, because you take away the camera view and then you have just the virtual content. All right, how am I doing? I've got about 10 minutes. So this last part is going to be a little more rapid-paced. LAR has an APK now for glass. If you want to live more in the LAR universe where you're doing stuff with Creator or you're using their web-based API, you can target glass, their application that way. They have a scan this component, pulls the content from LAR and shows it to you. You can do POI type content where you're looking around, seeing points of interest. There's a new one called ARPA. ARPA recently added glass support to their SDK. They have this part of the vision component uses a local database. Unlike Kachum, you add basically images to your app that get recognized as bitmaps. Right now, the capability is you can essentially just throw up an image based on whatever you recognized. Unlike Kachum, where you get just an ID of what was recognized and then you do whatever you want. In this case, it's pretty much a hard-coded experience. You get, you recognize an image, you get information about that image in the form of another image, and that's it. But it is super simple to integrate and use. They also have a POI-based geo application capability. You can configure some POIs in the cloud in your own database. Pull those. You can select a region of a geographic region that you want to limit the POIs to, and then you see them in your field of view. They've done an interesting thing where, as you're scanning, if the point of interest is in the center of your field of view, that's when you get the information about that item. You can tap the side of your face and get other menu items. Maybe you can get directions, for instance, from where you are. It'll just open up the navigation app. So it's actually an interesting integration with glass that specifically used the capabilities of glass for geo-based AR. And wow, believe it or not, I actually think I'm done with the content. Watch this space. I think come this time next year, we're going to see a Cambrian explosion of devices that you can play with. This year was exciting just to be able to get our hands on some of the eyewear that's available, but there's stuff coming out even this year that we already know about, like Meta and Athier. I think they're going to be at the show. Anyway, it's exciting times for augmented reality, exciting times for digital eyewear. Do we have time for, maybe we have time for 5 minutes of questions? What's the time? Yeah, if you don't mind, we can do, if anybody has any questions. Yeah.
This is kind of a broad one.
Oh, he's got a microphone. Here you
It's kind of a broad question, but having surveyed some of these APIs and tried to work with these different devices, is there something that jumps out at you as just not happening that you think should be happening? Is there something that seems glaringly missing as you look across different people's development?
I think I mean, one thing that I did mention already is this calibration issue. I think that's pretty huge. I think with the AR, especially with the see-through AR, I definitely would like to see a lot of energy put towards making that experience just super easy for the developer, making it super excellent for the end user, to get that virtual content aligned with the real world. You know, I'm kind of a little bit on the fence about whether the vendors of the eyewear themselves should be doing much more in their SDKs. I mean, while it's kind of nice that Google gives you these APIs to play with their device in a certain specific way, on the other hand, it's potentially a kind of a pain because you got to learn this whole other environment. Whereas you've already learned what it is to develop for a smartphone. You've already learned what it is to develop for a tablet. So some of these other vendors' approach is kind of nice in that way. I think, but that being said, I would like to see a lot of collaboration and tight collaboration happening between the vendors of the third-party SDKs and the digital eyewear companies, because I think that'll provide a better experience for us as developers as well as ultimately for the end users. So, but that's a great question. Thanks.
I have the mic.
Oh, okay. Sorry.
That's okay. Sorry about that. How would you imitate mouse movements on a robot that's controlling a robot with glass?
How would you, the question was, how would I control a robot's...
That's being controlled now by telecommunications via a mouse.
You mean a mouse or with your eye?
Well, right now it's with a mouse, and I'm trying to integrate glass to drive the robot. Right.
That's a really good question. I don't know. I mean, you could maybe use head tracking to mimic what...
The robot doesn't really have a head.
No, the person has a head, though, right?
Oh.
And, yeah, the person wearing glass. I mean, actually, there's Brick Simple has a demo where they control a robotic quadricopter with head movements on glass, and they can also use the gesture control on the device. It's really, yeah, it's kind of a little more of a human factors problem, I guess, than necessarily a development problem. I mean, there's obviously development things you're going to have to do. You have to establish a communication between the glass and the robot, but you've probably already done that if you're doing mouse input. But it's really mapping the control scheme, I guess, to what's available on the device, which is, sensors and gestures. I mean, I suppose you could use voice as well, but anyway, sorry, go ahead.
Yeah. What do you think of Technical Illusions and Cast AR? They claim to have solved the calibration problem, and it's projective AR, which is a whole new realm.
Yeah, I'm absolutely super excited to get my hands. I have not yet experienced Cast AR yet, so I can't comment necessarily on how well they've solved that problem or if they've solved that problem. But I have, I put in for the Kickstarter campaign. I'm really looking forward to using their device, but I wish I could say definitively whether that's that's true. I hope it is. So thank you. Okay, we got one more. Can we do one more question? Let's do one last question, then we'll move to the next speaker.
Thank you. If you consider see-through devices for daily use, for consumer market, how important is it to have a stereo display in your opinion?
How important is it for there to be a stereo display on a consumer device? That's a really good question. I guess it really depends on the application. I could see for gaming applications, it could be really important, and especially, and also if if you want to do a consumer application that's focused on repairing your bike or repairing your lawnmower when it breaks down or those types. I mean, if we're just walking around the street, I think it does add to the bulk of the device to have stereo. I mean, I would love for it to be stereo, lightweight, etc. I mean, maybe less important for a consumer. I don't know. But anyway, I think that's all the time we have for my presentation. Thank you very much.